This is our Tomahawk Metals proposal. I will be talking about the capacity analysis. So first we want to start with the available hours per machine. The plant operates 16 hours per day, 325 days per year. So available hours would be 16 times 325. And to find the year zero required hours, you would want to do the current utilization times the available hours per machine times the number of machines. And then for the future years of down 10 years down the line, you're going to want to use year zero demand times one plus the growth rate times t, where t is the number of years. And this can be seen throughout the Excel file. So for this one, you're using the 5,200, 2, and the 84 to get your year zero required hours. And then when you're compounding down for expected hours for year 1 through 10, you're going to use for 3, you're going to use 1.03, for 6, you're going to use 1.06, and for 9, you're going to use 1.09. And then, so basically the same goes for every single machine. You're using the same formula, but obviously different values that you determined with the year zero required hours. But the most likely demand you're going to have for the amount of hours per machine would be using the maximum and expected formula. So you're going to obviously take your year zero required hours, but you're going to you're going to have the minimum, which 3% here, multiply the 6% by 4, and then add on to the 9% divided by 6. And basically you're running through the same pattern, but you're as above, but you're using that specific formula. And then for utilization cutoff, we decided on picking 85% to trigger new machine purchases. This threshold was chosen as allows for a sufficient buffer capacity to handle fluctuations in demand, unplanned downtime, and machine maintenance while ensuring high efficiency. So you want to calculate the utilization for the 3%, 6%, 9%. And so this value up here is the hours, the expected hours for each machine. And this value right here, the 10,400, is from the available hours times the number of machines. So you have two machines there. So you do 5,200 times two. And then for three, you would do 5,200 times three. And all these yellow highlights show that we're above 85%. So that triggers a new machine purchase. And as you can see in the right-hand column here with the number of machines, it displays when you need to add a machine to your system to keep up with your demand. And that's obviously for 3%. But your best bet is going to be here with using the expected maximum and expected, as this will give you the best rough estimate of when you're going to need to add a machine to keep up with demand.
I'm going to be doing the factor analysis. So here are the factors we considered. We have material handling, safety requirements, storage, investment, ROI, which is the return on investment, flexibility, admin and support, noise, and maintenance. We gave each one of those factors a weighting scale from 1 to 10, 10 being the most important to consider, 1 being the least. We gave the highest score to ROI with a score of 9, since we thought that's the most important thing to consider for a business. And the least is noise, since compared to all the other factors, it's the least important to consider. To compare the two layouts, we gave each layout a letter grade to represent how well they do each factor. And here's the explanation for the letter grades: E being the highest with a 4, A being a 3, I being a 2, and O being a 1. And to get the final score for each layout, we multiplied the letter grade by the weighting scale of each factor to get the final score, and we added all of them up at the end to get the total for each layout. So, in conclusion, based on the factor analysis, layout 2 is the recommended option for Tomahawk method. It outperforms layout 1 by 21% in the total weighted score, being 166 versus 137. It's driven by a superior material handling, higher return on investment, better maintenance access, and reduced operational noise. Layout 2 offers a more efficient, safer, and aesthetically organized facility, directly supporting Tomahawk Metal's goals of sustainable growth, employee satisfaction, and customer impression. Although Layout 1 provides more flexibility for future changes, the long-term operation and financial advantages of Layout 2 make it the optimal choice for the new layout design. And
Now for our block diagrams and suggested final layout. Our first block diagram shows that there are high rates of flow between the machine shop area and the storage departments, as well as the assembly area and shipping and receiving, so those need to be close together. We also have painting needing to be far away from the lunchroom, which is because of the possibility of contaminating food with chemicals from the paint. Based on that first block diagram, we developed this overall layout, which has storage areas and assembly and shipping and receiving, etc., all near the machine shop. Our second block diagram has that same theme of the machine shop needing to be near storage areas and assembly, as well as shipping and receiving, and painting needing to be far away from the lunchroom. We also see that the administrative office and the president's office need to be near conference rooms and sales and accounting, which is something that differs from the first block diagram. So based on the second block diagram, we have this overall layout, which has shipping and receiving inside of the broader machine shop area, as well as painting, assembly, and storage areas connected to the machine shop. And we have the president's office and administrative offices near the lunchroom, as well as the conference rooms. Based on our factor analysis, we concluded that the second overall layout option would be more efficient. We also have diagrams for the machine shop, and in this first one we see that the lathe and the mill and the drill should be close together, while there is no reason for the lathe to be near inspection or for painting to be near grinding or tool storage. And in the diagram we have an operator aisle laid out, as well as a forklift aisle. In the second machine shop diagram, we see that the lathe should be in close proximity to the CNC mill and the drill press, and we see that the drill press doesn't need to be near inspection, and tool storage has no reason to be near welding. And so over here we see that the forklift entrance is at the top of the diagram, with the lathe close to the drill and the mill and storage area, and then an operator aisle followed by inspection and service grinding and painting and welding.
Now we're moving on to material handling equipment and key features of our facility. For material handling systems, we've got transport equipment such as forklifts for any bulk transportation, as well as conveyors for transportation between processing sites to speed up production and reduce labor time. We got positioning equipment such as hoists and cranes to lift any large unwieldy items and to position for welding. Unit load formation equipment includes the pallets, totes, and pallet wrapping machines. The totes will be used in conjunction with the conveyors at processing sites, and pallets and the pallet wrapping machines will be used for long-term storage, as well as any storage of items going into production. Storage equipment includes racking systems to effectively use our vertical space to maximize storage, as well as work in process storage for any temporary storage we may need in between processes for any incompleted product. Aisles in traffic, we've got 10-foot aisles for forklift traffic and 6-foot aisles for any administration and foot traffic through production. We got waste and recycling through scrap metal bins that are going to be used at the facility to promote a clean workspace and sustainability. For our key features, We used our block diagram and factor analysis to determine these and to make sure we emphasize them in our layout. For efficiency, we group the high flow areas to reduce travel time. We have a central inventory placement for quick access to materials. For safety, we have a clear separation between hazardous areas and general administration spaces, wide safe forklift paths, and designated heavy material lifting zones. Same goes with noise control. We separated the loud from quiet areas so we can have a safe and productive environment for those who require focus while still allowing to have efficient factory operations through those hours. With accessibility, we have support places near administration offices for easy access, wide aisles in key production areas, as well as having future areas open for expansion in operation.